Okay, good morning. It is 2 minutes past 11, so let's just start. My name is Bambang Paramanto. I don't know if the automatic translation will pick up my name or not. Welcome to the RERC on Information and Communication Technology Access State of Science. And welcome all of you in this room, as well as those who join us online. So this State of Science is streamed online, and we also try using automatic transcriptions. Sometimes it works, sometimes it doesn't, so our apologies for that. But this is an example of the technology that can be used and streaming and amplifying the event that we have, as well as providing accessibility for individuals with disabilities. So, and thank you to pit crew who have been working last night until late night to make things work. As luck would have it, we assigned a corner room with limited cell phone, almost no cellular connection, with limited Wi-Fi as well. And while our life really depending on internet connection, so everything we are doing, streaming, the transcription, everything depends on the cloud. So, we struggled last night on how to make things work. That's part of the engineering challenge that we have, and thank you to our crew who have been working on it last night and this morning. As things like that, it's always glitches, problems in the last minute. Yeah, that's part of the fun and the challenge. And thank you to Nidler, who has been providing the funding for this event, as well as the research that will be presented in this State of Science. And this State of Science is part of the RESNA annual conference, so it's not just co-located. It's really part of RESNA conference, meaning that all RESNA attendees are also welcome to this State of Science. On the other hand, everybody are registered to RESNA, although there are a few glitches with Jeff who's not registered. But that means that you will have free lunch today. So that's the good news. So you can join the RESNA lunch today. We tried this online State of Science 5 years ago, and we spent 6 months developing the technology, perfecting it, and then try to make it work. Right now it's much easier to do online streaming like this. So we spend probably, instead of 6 months, just a couple of weeks and to make it work. And of course, we have to stay up night to really make it work in the last minute. As you have all the booklet, so we have schedules there. So we have 4 workshops today, and with broad three themes, which also represent the broad goals of the RERC. The first one is how to mitigate the ICT barriers for individuals with disabilities. That task and that workshop will be led by Jeff. And by the way, Jeff is the co-director of this RERC. And then the second workshop is on how to use mobile health to empower individuals with disabilities. And Andrea Fairman will lead that session. On the third workshop, we will cover how to reach individuals with disabilities in the rural and underserved area using digital intervention. And Pat Skidmore will lead that one. On the fourth workshop, which is really late this afternoon, and hope all of you will stay, we'll discuss about how to move forward in future research in this area. So those are the objectives of the RERC, as well as the themes of the of the workshops. And because we have, the problem with, is part of the rationale, the challenge is that we are limited to the slots that we have, so which is 1 hour. We make it 1 hour, 15 minutes, and we provide coffee, so you don't need to go out to get coffee. And the bios of the speakers is on the booklet, so we don't have to introduce the speakers in this workshop. And without further ado, I'd like to have Ruth Brennan, who is the Director of Research of NIDER, who provide funding for this event to provide opening remarks. And Ruth, I'm sorry, sir, you have to. Thank you.
Well, I'm delighted to see such a large turnout here, and I just want to say a couple of things. One of them is in the plenary session we were just in, I talked about the fact that for a lot of our research now, it's not specified, it's not agency directed, meaning do research in this, as we've categorized things into broader areas, and majority, not all the research is open within these areas. So information and communication technology is one of the large areas, and we get significant competition whenever we promote this as a target area, and I couldn't be happier than the quality of the research that we received from Dr. Pramanto and his group. And yesterday, he was able to come over with a colleague to the Administration for Community Living, and we were able to get people from other parts of that administration who are mostly dealing with service delivery issues. As I said earlier, we're the only research organization. And in the session there, I got a very strong, and it really was focusing in on the health for people with disabilities component, which will be workshop 2. But the quality of the work, the depth of the discussion was really powerful, and it engendered interest from other components of the Administration for Community Living who want to work now with Dr. Pramanto and the other staff to talk about how we can make this research-based activity integrate into real-world settings and to really be able to help people with disabilities in the real world. And I think the reaction was strong enough that I don't for once think it was something that everybody nodded and thought was great and walked out the door and won't do again. And that's the kind of success that NIDER is here to fund and to support. It's not just doing the academic piece of it, but for us, it's the long-term outcome, and how is this going to be used, and how could it change the lives of people with disabilities. So I know for all of you, I don't know for all of you what your motivations are to be involved in the kind of work that you're interested in being here. But for us, it really is that this research make a difference. And I've known Dr. Pramanto for some time, and I think he represents the quality of people whose commitment goes the whole way. It's not just at the beginning, it's at the end as well. So I hope for all of you that you are able to learn from this, and that you find something that engages your enthusiasm and your commitment, and that you find a way to help us solve all the many issues that are facing people with disabilities, because it's a gamut of every aspect of human life. And so I thank you, and I thank you.
Thank you, Ruth, for your very generous opening remarks. So the first session, the first workshop is on ICT accessibility, and Jeff Bickham will lead that workshop. It's all yours, Jeff.
Yeah, good. All right, welcome everyone. I'm Jeff Bickham from Carnegie Mellon University. And so this session on ICT accessibility we have three speakers. So I'll give a brief overview of some of the work that we've been doing and others have been doing on mostly the web and how web technologies are changing and can be repurposed for improved accessibility. Then we'll have a talk about machine learning and accessibility. So AI is very big right now, and there's a lot of potential, and so we'll hear about how we can use machine learning for accessibility. And then we'll have Clayton Lewis be our discussant, who will talk about design futures for inclusive web design. All right, so this is me, this is my group. We have a large number of people at Carnegie Mellon working in accessibility, a lot of students, collaborators, colleagues. A lot of the work that we've done over the last 10 or 15 years really has been looking at how we can take the technology that's available at the time, repurpose it, leverage it to the maximum we can for accessibility, and how we can use some of the technologies out there to not just deliver kind of the base level experience, but to actually improve and repair accessibility on the fly. For me, a lot of this got started with a project that we called Web Anywhere, and we're still working on this today, which basically had this pretty simple premise, although at the time in 2007 or 8 when we started working on this, it was kind of revolutionary. The idea was that a person with a disability should be able to go up to any computer that they happen to have access to and be able to use it right away. And the amazing thing that was happening at the time was that the web was transitioning from being this platform of just static documents into a rich platform for applications. So web applications were kind of becoming mainstream. But what we realized at the time was that people with disabilities were not necessarily taking advantage of all of the kind of increased availability of their applications on any computer they happened across, because they didn't have the assistive technology that they needed to use those computers on all the computers that were around. And so we built at the time this project Web Anywhere, and the idea was that you could go up to any computer. It would provide, at first, kind of a screen reading experience, and then over the years we've worked on all kinds of different, building other kinds of assistive technologies into the web. So things like magnification, things like high contrast view, things like reading support, speech recognition, control of the interface. And one thing that I think is really interesting about kind of how the web technologies have changed over the years is when I was first writing this as a PhD student in 2007, I had to do a lot of work to make this possible, right? And so really crazy things like we couldn't speak directly on the computer without installing new software. And so what we did was we would fetch MP3s of every single sound that we'd want to make for the web page so that we could play those with the players that were available on the web. And this took a lot of back-end engineering. It had consequences for kind of the latency and the feel of the user experience. But what's changed is that due to efforts of people that are very much in the NIDLR community, web technologies have evolved in ways that better support accessibility and better support the prototyping, I think, of really interesting new accessible, inclusive experiences. So things like text-to-speech being natively available from within web pages in the web browser, speech recognition, just in general, the client-side web platforms becoming much more powerful. As just one example of something that my group and I have prototyped recently, we were able, within the web environment, to create an IDE, so an integrative development environment, that was completely speech controlled, right? So the idea that you could actually program without being able to type. And we could prototype this and make this available all from the web, right? Which is pretty interesting. Of course, something that's changed is that in 2008, you think about the cell phones you had back then, and they were way different than the ones we have now. And so one thing that's definitely changed is the increased power of mobile. And especially with devices like the Apple devices that are incredibly accessible, and Apple takes a lot of care and pride in making their technologies accessible. But one thing that I think is interesting, as I'll get into this a little bit later, is how the web, because it's this open platform, allowed us to experiment and try out a lot of the different approaches that are now making it into even these mobile platforms. So interesting. It's interesting, the parallels there. So while the availability of assistive technology has increased dramatically because people can carry around their own personal phones with their preferred assistive technologies and settings, the ability to kind of prototype that quickly and easily in a way that can get out to lots of people still has relevance for the web. All right, so so what hasn't changed? So one is, I was kind of already alluding to, one is that we continue to be able to use the web as this really interesting foundation for delivering new assistive technologies. And so we've added all kinds of interesting features to Web Anywhere over the years. Recently, we did a really interesting prototype of a system that essentially turned the keyboard, so this keyboard you have here, instead of basically experimenting with a new interaction mechanism for how a screen reader user might interact with complex information. So instead of having to memorize a whole bunch of shortcut keys, which is what experienced screen reader users need to do to be efficient, maybe they could leverage the two-dimensional space that's afforded by this keyboard to navigate the layout of information. So we were experimenting with tables and navigating the web using the relative positions of the keys as ways to navigate through the kind of logical page structure that the developer, who probably didn't think much about accessibility, nevertheless put into the page because they wanted to make the layout useful and appealing to mostly sighted people. The other thing that we were able to do on the web, and there was a large push on this, and we did some work on this, others have, on third-party client-side fixes for accessibility. So the idea is that it's unfortunately been the case now for a couple of decades that it's really difficult to convince all web developers to make their web pages accessible. And so if you want to hit that long tail, which is actually pretty important in aggregate, maybe we can have third parties who care about accessibility go in and fix the web pages that weren't created properly. And this is still happening in various ways in the web. And what I think is really interesting, and again, as a precursor of how the web technologies kind of allow this kind of prototyping and figuring out how this might work, this is now being done for mobile applications, right? So now as mobile has become even more important, now we are thinking a lot more about, well, how do we make those mobile applications accessible? And so there's now a large or a growing body of work looking at how do you take an application that was written by a developer who maybe didn't know about accessibility or just didn't do it right, and fix the accessibility of the application at runtime. So basically have another app that's observing the mobile app running on your phone and fixing things where it can. So adding new sorts of labels for items that don't have them, changing some of the widgets, so from an inaccessible widget to an accessible one. There's an example here of Yelp on Android didn't allow screen reader users, so talkback users, to actually hit the star ratings, right? So what this work does is insert an overlay on top of the running application that produces a star rating widget that is accessible. And so I think this is really interesting. And again, I can draw these connections between what we were able to do with the web and this kind of early and open platform and what now is happening for mobile. All right, so what's new? Well, there's lots of things that are new. One way I like to think about it, and I'm going to go through it in the last 5 or 10 minutes of this talk, is to talk about what the web can do for learning about accessibility. And so I was able to design and teach a new course to the students in computer science at Carnegie Mellon, teaching them about accessibility, and not just the design, which I think is really important, the design aspects of how do you create accessible and usable experiences, but how do you get people excited, these really technical students that we have in our computer science programs, how do you get them excited about building accessibility and working in accessibility? I think one of the ways is to describe the work that we do in accessibility as this really interesting probe into what future interfaces might actually be, right? So if you think about the earliest adopters of some of the now starting to kind of make it into the mainstream technologies that we think are really exciting, like these speech-controlled devices, or computer vision's kind of working a little bit better than it used to, or even speech recognition. Often it is people with disabilities, right? And so if you want to get an early look at what that technology is like with users who are actually really using it now, as opposed to kind of just seeing it as a cute toy, oftentimes accessibility is where you can do that. All right, so some of the projects that we had, not surprisingly given our experience with Web Anywhere and making a screen reader experience on the web, we had projects where students built web pages that were self-voicing, right? So that initially the first project was, can you make a web browser extension that would turn any web page into a self-voicing one, so that someone who either couldn't see the content or could benefit from it being read to them could hear it. And so it had, I think, 45, 50 students, all create that experience. You can go online and see a lot of the videos of me talking about that. We went all the way, so again, 45, 50 students, these amazing computer science students at Carnegie Mellon created a screen reader for the web, right? So this is, again, a web browser extension that would provide a screen reading experience for the web. And so now we have 50 students who all created a screen reader, right? Which is pretty cool. We had magnifiers. And again, this web technology is pretty cool that you can do all of this. You can explore different kinds of magnification, right? So you can do graphical zoom, or one of the things that the browser is really great at is it does a lot of the reflowing of content, so that even as the content gets big, you don't have that introduction of these horizontal scroll bars, which are really annoying and frustrating to use. And so we were able to play, again, with these 50 students with not only implementing magnification, but actually implementing different kinds of magnification and understanding the different trade-offs and how you might combine them and where you might use one versus the other. We built a single button input, which was like, kind of mind-blowing for these students who didn't have any experience in accessibility before. So I showed up with this big button, and I said, you're going to build a browser extension, again, that lets somebody browse the web using this one button. And so we built these into the web. So here's a little video, if it plays, of here's a little section of a web page, and we just had the scan bars, and you could click with that button. And they tried out different methods. They got to experience this as they were testing it. They said it's so slow. Why can't it be faster? And then they tried to make it faster, and they tried to think of all these different ways that they could improve the efficiency of clicking through a web page with this sort of thing. We also looked at, well, maybe we can improve the accessibility of these web pages. One of the big problems is that developers haven't done everything they could to make their web pages accessible, their mobile apps accessible. But now we have AI that's starting to look like it might be useful in different situations. And so they built an automatic image labeler using the Amazon Recognition computer vision service. And so what they were able to do then is you load a web page, and they had to make these really hard decisions, though, about, okay, so the service came back with a description. Well, should I apply that description to the image or not? What if there's already a description? Do I know whether that's a good one or a bad one? Do I add it to the end? How do I help people understand the confidence of the service, right? So it'll give you a confidence level, but what does a person do with a description that's 60% likely to be right? So really interesting and hard problems that I think we'll have to solve from both the design and technical side if we're going to make use of this stuff. And so they all got to all prototype all of that. And just to go into this, I think that there is this really interesting potential going forward for using different AI technologies for accessibility, but it's not straightforward, right? So one of the really cool things that Facebook did recently was, they started adding alt text to all of their images using their computer vision service. And this is really great, but there's lots of questions that it brings up, right? So one is, well, why didn't Facebook allow the user to provide alt text? Because that alt text would almost certainly be better, and maybe they wouldn't have provided it. Certainly very few users provide it on Twitter, as we're finding. These tags, are they useful? They're pretty generic. They're high-level things. They're things that the computer vision might do reasonably well at, although sometimes there's errors, which is another problem. But how much of this is different than what the user would have gotten from context anyway? And it can be really dangerous to provide an incorrect alt text, even if you kind of say that you're not sure. So here's an example. This is a study that was done at Microsoft Research by Mary Morris and some colleagues. So the picture here is Hillary Clinton getting up on stage at a rally or something. And the correct alt text is something like, image shows Hillary Clinton walking onto a stage in front of a large crowd of people. Like, that might be good. The automatic image describer that they had at Microsoft actually said, a man on a trick on a skateboard at night, or a man doing a trick on a skateboard at night. And they asked people in a user study, they said, well, can you describe this? Why do you think that's the do you think this is right or not? And a lot of people came up with justifications, even when they were told that, this was produced by this automatic service that may or may not be right, for why that might be an accurate description. So they said things like, well, maybe Hillary is trying to appear young and hip, and so she's got this picture of a young man on a skateboard doing a trick on her social media page. And so it's just not, it's not obvious, how we should deliver these and how we should convey our uncertainty in descriptions like this, even though I think there is this huge potential for using this sort of technology. So just in summary, we have seen a lot of changes over the last 10 years, a lot of really interesting developments in technology and our understanding of how to deliver experiences. I think that many of the fundamental problems, though, and opportunities, have not actually changed that much, right? So we still are faced with the continual production of web applications or mobile applications that are not done in an accessible way. And we're still kind of figuring out how we can make them more accessible. I think there's a great opportunity, especially with the changes in web technology. It just makes it so much more available to students to be able to try out building actual assistive technologies, right? And so we can actually, in a semester-long course, have students build some version of most of the popular assistive technologies in some way. And I think that's really powerful, right? So there's this growing accessibility profession. I think we need to plug into that students who are excited not only about kind of the impact they can have, and I think that's really important, but also just about the really interesting and hard technical challenges there are in accessibility. And I think there's this great potential for AI to help going forward, but I don't think we should rush in and just think that it's going to automatically solve all the problems. I think we need to be deliberate and careful and understand how we can deliver it to benefit people while minimizing the cost. So thank you. There's some URLs here. You can try out Web Anywhere. You can go to the accessibility course to get the materials that we produced for that. And yeah, thank you.
You can sit there. Yeah. And just in case, this is also active. Just turn it on. Right. Yes? Yeah.
If you have any question, please just hold on until we have three presentation, and then followed by question and answers discussion.
Check. Check, check. All right, thank you very much for this opportunity. I'm going to present our work on the use of machine learning for web accessibility assessment. As we all know, right now, accessing the web is an essential skill to survive. However, access to the web itself can be difficult for some populations. The latest census says that 20% of our population has disability, while on the other hand, web technology has advanced so much, making it more dynamic, a lot of interactivity, what Jeff has been explaining, and these advancements can work for or against users with disability. This leads to questions of how accessible the internet itself. The short answer is, well, we don't know. We have a large spectrum of internet users accessing the information resource on the internet every day. Each of these persons have different accessibility requirements. So what's accessible to one person might not be accessible to others. All the content access guidelines that has been created are geared more for designers, which means that interpretation of designers also comes into play. What a designer considers as accessible in one website would probably be different with what other websites would consider as accessible. And based on a survey conducted by the WebAIM group, over the past 5 years, users' perspective on accessibility has not changed. So there is an absence of an automatic web accessibility evaluations that can help us answer how accessible the web is. However, we have seen no major effort that measure the overall or aggregate the web accessibility itself for the past couple of years. And even if there is an effort in measuring or assessing the accessibility of a website, it's usually very specific, only on a single website to check for compliance. And the success criteria listed on the guidelines are usually geared for a human to test. It's very difficult to verify it using an automated test tools. Therefore, our approach in developing the web accessibility, an automated web accessibility evaluation tool can be comprised in 3 parts. The first one is we identify prototypical websites. We sample the web based on the popularity as well as their function. The second component is the development of a web accessibility barrier metric that will help us to measure how difficult or the number of barriers that an individuals with disability will encounter when they access the information resource on the internet. And the third part is the development of a machine learning based automated web evaluation to model a human assessment. Depicted in this slide is the concept which will allow us to measure the overall accessibility of the web. The components within that engine can also be used on a personal level to provide adaptive accessibility. Adaptive accessibility is an idea where we can augment adaptation of individual products and service with automatic personalization. In our approach, we use 3 steps to deploy this. The first one is we measure the accessibility of the information resource on the internet. The second one is we measure the person's ability. And the third one is we use machine learning to adjust the information resource to the person's ability. Let's take a look a little bit about how our system works. This video here depicts our tool. Okay, and in our automatic evaluations, we can copy and paste any websites and then allow our system to conduct an automated evaluations of the barriers. We can explore the details and specifically understand what is the barrier that is being presented on the website. We can also take a look at the specific locations of each of the barriers being presented on the website. So all those reds are depicting the potential reading barriers in a website. These locations can be used as a part of a readability adjustment that allows us to simplify and reduce the complexity of reading for our users that have lower reading ability. Our preliminary result from the evaluation shows that in the perceivable and operable component for accessibility, we have a good results, mainly because a lot of the effort in the internet has been focused toward making the internet more perceivable and more operable. The understandable component of the web accessibility is still challenging, mainly because if we need to create a content that is understandable for different level of understandability, then the designer of the website will need to create multiple versions of the website. And this is where we focus our effort, introducing machine learning to adjust that accessibility level automatically. I'm going to pass this now to Dr. Raching He to discuss more about our magic behind this automatic adjustment.
Great. Okay, good morning. My name is Daching He. I'm at the School of Computing at the University of Pittsburgh. And so we collaborate with Ben and Andy on this project. And we mainly focus on developing technologies to support web accessibility. So as Andy pointed out, that the main things relate to the web accessibility is mainly focused around understandability. So we try to develop technologies to support people to understand, or at least to help us to assess whether people can understand that web pages. So the first thing we work on is to automatically predict the readability. The reason that we focus on readability is we think this is the starting point for people to understand the web page. If the page is too difficult for people to read, then that's really become an issue for people to understand. So the first thing we work on is understandability. And traditionally, there are many measures for it, like this FKGL measure, but mainly they focus on looking at sentence complexity and also the word length. So it is one measure fit for all kind of method. What we want to develop eventually is a personalized capability to assess whether a page is accessible for the people. Therefore, we use machine learning techniques to automatically predict whether certain website is too difficult. And the model that we work on is to think that the readability is really related to how many surprisal words in a sentence. We define the surprisal word as a word that's really out of the context. So that if we model the sequence of a sentence, and based on the context in that sentence, we can see how surprised a word is out of the context. And we can use that to indicate whether the sentence is difficult or not. And the way of modeling the surprisal can come from a particular set of documents related to a user's capability of reading that kind of web pages. And in this particular implementation of our model, we use the embedding of the word embedding, as a way to incorporate the context. So that's the diagram shows that each word in a sentence now is being modeled as embedding kind of dense vectors, and then we calculate the similarity between the context and individual words in the sentence. We will be able to predict the surprisal value. And then we test our ideas on a particular set of documents, and those documents come from a website called Newsera. The Newsera is aimed for people to learn language, so therefore they provide different versions of the same document with different readabilities. So it's human-generated kind of different readability version of the same document. So we can use that to learn the context information about different readability levels, and then we use that to predict whether a particular article is at the same level or too difficult or relatively easy. And we tried this on 3,400 documents on the web, and our result indicate that compared to the traditional this FKGL measures, we actually achieved the best, kind of much better, significant better in kind of performance. And we also have the capabilities of changing the different parameters, including the context length as a way to tune the model so that the model can be more flexible to help people. And the second things we work on is, like Andy shows you, that once we identify which part of the sentence, which word is difficult for the users to read, then this gives us opportunity, give us a target that we want to simplify the sentence. So the next step we want to do is the sentence simplification. And there are many ways of doing sentence simplification. Like, for example, we can shorten the sentence, we can change the structure of sentence, make it simple. So right now, we focus on the first step, which is to change the difficult words to a simple word. So kind of replace difficult words with a simple words. And we model, again, this as a machine learning problem, and we treat the whole sentence transformation as kind of translation, but during the translation, we replace difficult words with simple words. And we also use the sequence-to-sequence modeling as a way to model the context, and so that we can predict what words to use in this context. We also utilize an external resource called PPDB, which are kind of external database people develop it when people develop capability to perform paraphrasing of the sentence. And that tells us for certain words what would be difficult words and the simple words. And what we want is to combine this external knowledge base with the particular sentence context to accurately predict which simple words to use. So that's our model. And we also tried it on large collections of materials, close to 300,000 sentence pairs to test it. We also tested this simple Newseller documents. Again, we tried different versions of the models, and the result indicates that indeed we can improve the capabilities of simplify the sentence compared to some of state-of-art capabilities. So this helped us to develop this particular capability of simplified sentence. Of course, right now, what we developed are just core technology. We're going to test it on the real people. We're going to recruit people with disability to let them to read, to indicate which part of the web pages are difficult for them, and then we let the model to simplify the sentence for them. That will be the future work for us to work on. But right now, what we present is just the sentence capability. Yeah.
The Clayton. Just press it. There we go.
All right, and then we'll have our last speaker of this session, Clayton Lewis, who's our discussant.
Good morning. It's great to have the chance to comment on this really interesting work. And as the sort of title of my piece indicates, I want to use a particular framework for kind of locating what we've been hearing about in a strategic picture. So at a high level, there are two contending strategies for the long-term future of accessibility on the web. And these are due to people that some of you will be familiar with. So probably many of you know Greg Vanderheiden, these days of the University of Maryland. And Greg is the creator of the infobot concept. So this is one vision for the future of the web. So the infobot is a kind of a hypothetical entity that can read and understand any information that a typical person can understand. So no requirement that it be Einstein or that it be able to understand everything, but it has to be able to do as well as typical people would be. And having understood this material, it's able to present it in a form that works for any particular person. So for example, if you have a web page that's inaccessible for someone who can't see because it's not appropriately marked up for their screen reader, which is, I'm sure everybody here knows, is an extremely common problem, not to worry, because if the page as presented to a sighted person, a typical sighted person, is intelligible, then the infobot can take it from there. So to take I think a pretty concrete example, something that happens every day is that a sighted person creates a web page that looks like it has headings. So it has certain things in bigger fonts and maybe in bold, and a typical sighted person recognizes, by George, that's a heading. Well, probably everybody in the room knows that if that's not tagged properly today, a screen reader can't recognize it as a heading, and hence the page can't be consumed by somebody who's a screen reader user. The infobot can recognize that it's a heading. Why? Because typical people can as well. So that's one vision of the future of accessibility, that we put our collective efforts into making better and better infobots capable of consuming more and more material that today is not accessible. The other view lacks a really good name and isn't as visible out there in the literature, but there's a little bit of stuff on it. And these are ideas that are due to T.V. Raman, who's a distinguished blind computer scientist and mathematician at Google, and Jason White, whom some of you may know. Jason is at Educational Testing Service. So between them, they've promoted an alternative view, which is much more radical, really, or maybe even, than the infobot. You may think the infobot is described as kind of science fiction. This other idea cuts even deeper. And the notion here is that the creation of content will be done in a fundamentally different way from the way it's done today. So the way content is created today is almost all the time, if it's created by people, and I'll explain the hedge in a minute, what happens is that the person starts by creating some presentation of the information. And if they're a sighted person, the odds are they're going to choose to create a presentation that's easily consumed by sighted people. So they don't start with what the content is, they start with how they're going to present it. And the argument is that's strategically wrong. We should develop an abstract way to express content that's not tied to any particular sensory modality. So we could call this the amodal representation view. So instead of making that visual display and then worrying about how to make that accessible, you don't start there. You start by developing an abstract representation of the content, and then you have means of generating presentations of that abstract content in a form that works for people with particular capabilities. So if you need to present the stuff to somebody like Raman who can't see, then you're going to create, say, an auditory presentation or perhaps a tactile presentation or something like that. Let me pause. Does this idea of an abstract amodal presentation make any sense? I'm getting at least some nods there. I think it's pretty apparent what the appeal of the infobot is, but maybe I need to say a little bit more to motivate the amodal presentation idea. Here's one example. Think about textbooks today. So today, different books are written for every grade level, more or less. And this has certain easily predictable consequences. If somebody learns something new, then this new knowledge needs to be pushed out in indefinitely many separate places. In the world of amodal presentation, there can be a single body of content, and that single body gets updated to reflect new knowledge. And from that single body of content, presentations as needed for particular audiences can be developed. So there's some considerable cost saving there. Another point is, I put the hedge in a minute ago. If a web page is being created by a person, you may possibly be wondering, how else could it possibly happen? Well, I'm pretty sure, I don't know that anybody's ever counted this, but I'm pretty sure that even the great majority of web pages that are out there today are not created by people. They're actually created by content management systems. So, think about, you're ordering something on Amazon and, you look up alarm clocks or something. No human being created that page. It was created, it didn't exist before you asked for it. So it was created dynamically by automation. It's interesting, I think, that a lot of work that's being done actually in processing presentations and content are actually more motivated by the requirements of automation than they are the requirements of human beings. And the abstract presentation of content has considerable advantages that way, at least today. So content represented abstractly has a better chance of participating in various automated reasoning processes, which are likely to become increasingly important. To take one example that I've found interesting, how this is cropping out today, there's a lot of work that is of interest to this group in the particular area of analyzing visualizations of data. So graphs and charts and that kind of thing. So how can you take a graph and chart and extract an abstract presentation of that information? So for instance, how could you recover a table of data from a graph that's being published? As I described that, we might all be thinking, well, this is great. This is being motivated clearly by somebody who's worried about how blind people can consume these infographics. And indeed, there are people who worry about that. But the people who are doing this work are mostly not worried about that at all. The reason they're interested in extracting this information from graphs and charts is that they want to make it available for things like search engines and other machines who today can't access and hence can't index the information that's in a lot of scientific papers, because to start with, the graphs and charts are just kind of blobs that have no accessible content. So the accessibility event that's motivating this work is machine accessibility rather than human accessibility in many cases. So the amodal view is also in line with that. But there's a further point. If you really think about what's involved in the infobot world, there's a point at which there's going to need to be a way of capturing in abstract form what the infobot reads when it reads something. Because the combinatorics of supporting many, many different audiences with different sensory and cognitive kinds of capabilities, it's kind of impossible to do that if each input medium needs to be mapped to a specific output medium. It's going to be much more efficient to go through an abstract representation. Well, I don't know if I've sold you on this idea or not, but let me now turn to my discussant role. And I'll first observe that the work we've heard about is definitely aligned with the infobot world. So maybe some of you will be contrarian and think, okay, everybody's doing infobot. I'm going to work on the amodal view. That would be great. I'd be delighted if you would do that. Pulling out one point from Jeff's interesting presentation, I'm especially interested in his brief comments about tactile representations using the keyboard. So a couple of comments there. I think strategically the lack of widely available tactile devices is a limiter in a lot of what we're doing in accessibility, but including what we're going to do in the web. So I know many of us have really oriented our work towards doing things that sort of anybody with a web browser can do. Well, we just don't have good options there in the tactile world. And in part largely because it's a hardware kind of thing. But I've come to feel recently that this is even more important than I would have thought. So I've spent the spring working at the Diagram Center, part of Benetech, that some of you know about, working on inclusive learning materials, and in particular, inclusive mathematics. So we've made a lot of progress, actually, in supporting the sort of symbolic aspects of mathematics, sort of doing algebra and that kind of thing. We're developing a tool called MathShare, which, if any of you are interested, we could talk afterwards about what that does. But one of the things we've learned in taking MathShare into classrooms is that a lot of mathematics in middle school, which is where we're aiming, is no longer sort of pushing symbols around, numbers and X's and equal signs and stuff like that. It's highly diagrammatic. And there's good reason for doing that. There are things called tape diagrams that some of you might know about. They were certainly new to me, which offer, I think it's clear, much better ways of working on the notorious word problems than the conventional kind of symbolic techniques have. This raises a huge inclusion issue, though, as we're finding. How are we going to support this kind of highly visual, highly spatialized kinds of diagrammatic representations for blind learners? A major challenge there. To up the ante further, some of you will know the phrase embodied cognition. So this, for a while, has been a theoretical thrust within cognitive science and to some extent within education. But more and more is being learned about the power of body movement, including things like hand motions, gestures, and things like that, and the powerful role these kinds of things play in learning. Here's an example that's in my mind, so I'll stick it into your mind as well. So Dan Schwartz, who's now Dean of Education at Stanford, told me about a series of studies that stuck in my head that I think raises really interesting challenges for making education work in an inclusive way. So imagine that we have two beakers on a table in front of us. The beakers are of two diameters, a thin one and a fat one. They're both the same height, and we mark on each beaker at the same level a notional fluid line. So there's no actual fluid there. There's just a line showing us where the fluid would be if there were any fluid. And now we're asked, which of these beakers would we have to tip the most to get it to start pouring? Okay? Finding number one, this is really hard for people. If you just ask them to look at the beakers and answer that question, people find it a very difficult question. That's finding number one. Finding number two, if you let them handle the beakers, the question becomes easy. Notice there's no fluid. They can't do the experiment. They're still having to think about it, but they find it easy if they can handle them. Finding number three, if you make people think about the problem first before they handle the beakers, and then you let them handle the beakers, it doesn't help. Okay? So what that's saying is the sort of body motion, the physical examination situation plays a huge role in allowing people to understand a situation like this. So a challenge for all of us is, how can we make that work for people who can't see? How are we doing on time?
We had time. We did pretty well, so you've got...
Okay, all right, great. Should have checked earlier. Let's turn to the machine learning work. I'm very excited in what we were told about the applications of machine learning in making text more understandable. This is clearly a very strategic area. And I'm particularly excited in the recognition in the work that this is something that fundamentally is going to require personalization. So most work that's been done has just said, well, there's fourth grade level, fifth grade level, and so on. Particularly in the world of people with cognitive limitations, these grade levels just don't work. So if you're an adult with a cognitive limitation, you have a limited vocabulary, but you don't have the same vocabulary that, say, a fourth grader does. So the aspect of the work that promises to tie the transformations of materials to information gathered from particular individuals, I think is very exciting and very promising. However, I want to also note that there's some big challenges remaining, and I don't mean that our presenters would disagree with this. So I've spent time this spring out in Silicon Valley interviewing anybody who would talk with me about the potential of machine learning to assist people with cognitive limitations. And these have been very interesting conversations. And one form, one sort of subpart of these conversations very commonly is this. People say, yep, we're really making great progress in machine learning. It's really working well. There are all kinds of things we can do. But we're getting hardly anywhere in actually understanding text. Okay, there's a distinction here, transforming text and understanding text. Okay, so everybody knows, I think, that things like speech recognition, which is a form of transformation, transforming language from one form to another, that's working increasingly well. Machine translation, translating from one language to another, that's working increasingly well. But even in the case of these things, it's easy to come up with examples where the correct translation rests on actually understanding the text, not just putting it from one form into another, but actually understanding it. And the people who are doing this work say that remains extremely difficult. So let me give you an illustration in practical terms of the force of this observation and the challenge that perhaps some of you will take up. So I'm going to read a short passage to you. This is from a description of a Medicaid waiver. So occupational therapy services involve the treatment prescribed by a physician to develop, restore, or improve functional abilities related to self-help, adaptive behavior, and sensory, motor, postural, and emotional development that have been limited by a physical injury, illness, or other dysfunctional condition. It involves the use of purposeful activity interventions and adaptations to enhance functional performance. So that's the bureaucratese definition of this particular waiver. Here's the translation that was done by an editorial team, including self-advocate Nancy Ward, who's a very experienced editor. Occupational therapy services help with day-to-day activities and testing to see if you need special tools to help you eat, work, and live in the community. So I think you can agree that those patches are pretty different. But what I want to call attention to is that they're not different just because some words were replaced by some other words or some sentences became simpler. What happened there was that Nancy and her co-editors understood what that first paragraph was really talking about. And that's what they described. The passage didn't have that information in it. So one of the key challenges here is that if we're restricted, as techniques largely are today, in dealing with what's in a passage, we can get some useful stuff to happen, but we're not going to get this kind of thing to happen. We're not really going to break through and make it possible. Somebody says, oh, now I know what you're talking about. And that's because the machine learning techniques of today aren't able to actually relate the text to things outside the text. They're very good at understanding increasingly good, I should say, in understanding relationships within the text, but understanding things that go outside. The prominent cognitive psychologist Walter Kinch refers to this aspect of reading as constructing the situation model. So people combine the information in the text with background knowledge they have to construct a model of what the text is about. It's not all there in the text, and true comprehension involves that. And machine learning researchers are recognizing that this is a barrier. There is some progress being made there, which we can all hope to profit from. So I'll mention two kinds of advances. One, machine learning researchers are making some headway in developing machine learning systems that can manage external information. So to carry on a conversation that refers to something else, like information in a table. So Percy Liang at Stanford and his collaborators have had some successes in having this kind of conversation that's about something that's external to the text of the conversation. Pretty primitive so far, but promising. Another thing I'll mention, Paul Smolensky at Johns Hopkins and these days collaborating with people at Microsoft Research are making headway at developing new and more powerful representational techniques that are able to make some of the kinds of inferences from text that is going to be involved in creating a situation model. So those are a few comments on the discussions this morning. It's great to hear about this kind of work going on. I also refer back to what Jeff was saying about the power of innovation that's associated with work on inclusive design, the potential that that has there to improve life for everybody is really there. So I think we can all look forward to an exciting future for the work that we've been hearing about here. Thanks.
So we have a few more minutes. So you've heard a lot, 3 different talks. If there's any questions, I'm happy to we can take them now for any of the speakers. Yeah, and I guess we should probably, let's see if, I'll bring the microphone around.
Hi, my name is Nathan Moon. I'm a researcher with the Wireless RERC at Georgia Tech in Atlanta. I just want to thank you all for some really outstanding presentations. Much of my work pertains to mobile device accessibility, so it's smartphones, wearables, and increasingly smart home devices. And what we're seeing in that space are the ways in which voice recognition and voice control and increasingly the use of intelligent agents, whether it's Siri or Alexa or Cortana, are changing the ways in which we think about accessibility. And we're looking at the ways in which users with disabilities are using these devices. And it's almost as if there's an increasing amount of agnosticism about disability, that a user who is blind or otherwise cannot see a display can use voice control in the same way that a person with some sort of dexterity or hand or mobility impairment might use that device. It's almost as if we're collapsing the notion of accessibility. And as I listen to your presentations, I'm wondering if there is a potential for or some sort of convergence when it comes to web and computer accessibility, whether the sort of ways in which we're having to think about accessibility, especially as intelligent agents become kind of embedded in the computers, the ways in which you can now use Siri to do things on a computer, even access the web, or use Cortana in the same way, are changing the ways we think about accessibility. I guess for me it's largely a question of input-output, whether that's changing. In earlier times, you know, if it was a matter of output, you're a blind user, you use JAWS. If it's a matter of input, you've got some sort of dexterity impairment, you might use dictation software of doing that. Is that still there? Are we becoming more, I guess I'm asking, are we becoming more agnostic about what specific disabilities or specific impairments users have, and should, or do we even maybe even care about that? I think Clay was kind of touching on that, and that sort of kind of those two models of looking at it, especially that second one where you think about an amodal way of looking at accessibility. Is there a preference? And if we're moving away from looking at specific types of disability, are we losing anything in that process, even as we're pushing towards greater accessibility for all? There's a lot out there, but just thinking about maybe some convergence in the way in which we're rethinking input-output.
No, you can take this.
Yeah, I think that's a great point, Nathan. So I mentioned I've been working in Silicon Valley, understanding some of these things, and the growth of that personal assistant space is pretty staggering. And one of the things that's interesting about it is that it's organic growth. There's nobody up there sort of pulling wires and making it happen. And one of the things that is happening, as you're saying, is it's creating huge accessibility gains. So I think there is a lot of promise there. It's also interesting, I think, to think about what the underlying representation is of these skills or activities or whatever. Different platforms have different names for them. And mostly you'd say at this point it's code. So a particular Alexa skill is a little program that somebody wrote. And then is code amodal? Well, there's a sense in which it is. So I share your enthusiasm for this stuff. I'd note, sort of relating it to another theme here, where this growth, positive though it is, doesn't seem to be making headway is dealing with things like spatial concepts and things of that kind. So those are difficult to deal with using the sort of conversational metaphor that's often involved in these interfaces. But I think you're right, this is happening. It's clearly having enormous benefit for lots and lots of people with disabilities. But as usual, there's going to be more that we have to do, I think. But excellent point.
Great. I guess a couple of things. We definitely saw this with the introduction of the iPhone and the various accessibility features there, where people definitely appreciated being able to use the same iPhone that everyone else used and having all the accessibility features built in. That was a big deal. I think, unfortunately, every time there's new technology, there are all these great use cases where people benefit, and then you start to think, well, what happens, say, if speech control is the only way to access something? And so we've been doing projects on how deaf and hard of hearing people could access a speech controlled device, which is fairly backwards, and nobody actually wants to interact with these systems like this. But there starts to be, I think there are examples like you go into a hotel room, one of these like fancy hotel rooms, sometimes in the Silicon Valley, and they have like these smart speakers that are the only way to access certain functionality in your hotel room, and not all of them have an alternative interface for being able to do that. And it turns out that Alexa, there's no way to type to Alexa. You can type to Siri, and that's great. But all this interesting stuff that happens. I will say, just like at some broad level, right? We've been talking about for a long time, right? The idea that the eventual merging of these dialogue systems with screen readers, right? And you think about it even today, like the gap is still pretty big, right? So most people only do one or two things with their smart speakers. They're getting better, but it's actually pretty limited. And then imagining that eventually transferring into something like the infobot that you could ask anything or have a conversation about the web instead of viewing the web. Definitely a possibility, but it seems like it's a fairly long transition that'll happen. Any other questions?
Thanks. Seems like a lot of the presentations this morning and a lot of the discussions about accessibility have focused on interface, especially blindness, but also hearing limitations. Assuming that a user is of average, I think the term was even average intelligence, but what I'd like to ask everyone here is the technologies as they're developing, are either of them, whether it's the amodal approach or I'm sorry, what was the term, Clayton?
Infobot.
Infobot. Those two approaches, for example, does one hold more promise for the user who has cognitive limitations? Or do any of these emerging technologies consider those users who are going to have cognitive limitations? And you may present the material very clearly for a person who has those capabilities to understand. But is there a way to improve the accessibility for somebody who doesn't have that?
Assume Clayton has something to say.
I think in the long run, both approaches can work out. In the short run, neither of them is real great. So as I tried to indicate, our ability to really do useful text transformation remains limited. I mean, it's improving, but it's limited. So there isn't anything that can do the kind of thing that Nancy Ward did today. Is it going to come sometime? Maybe yes. On the other hand, in principle, the idea of being able to specify something like a definition of that occupational therapy service in an abstract way, the techniques to go from there to a presentation that's more understandable, maybe that looks a little bit easier, but right off the bat, we lack today an adequate approach to this kind of abstract presentation. So I'd say that there there are different issues with both of them, so this remains an area in which human effort is needed. Maybe I'll throw in a comment here. I had a chance to talk with one of the people from New Zealand, so this was the organization that's mentioned that produces these multiple grade level versions of news stories in particular. They're paying the price, literally, of human editors. And the reason is, today, they don't think that the technology is available to actually do that. They're very interested in developing it, but they say it's not there. You look at the kind of coherence that results from a human-edited passage, which is very important to making the stuff readable, and they're not seeing it in the technology today. Will it be there someday? Presumably, but it's tough.
I guess I'll just add one thing. I mean, I think we can fall into this trap of assuming that AI, machine learning, has to do the entire job, whereas probably in the near to medium future, where we'll see the most benefit is using AI, machine learning to help, say, the editors, right? So there's been great work in speech recognition. So if you need high quality speech recognition, using the speech recognition signal along with the human signal and figuring out how that collaboration works. So it's actually not trivial to take, say, a highly errored speech recognition signal and have a human kind of fix it up. And it's also worked in translation. So Jeff Hare at the University of Washington has done work where they use automatic translation not as the final output, but to assist the human translators in doing their jobs more quickly. And so this may also apply in simplification, right? So we might be able to figure out ways not to do the simplification all at once because, bringing in all the context from common sense that AI has so much trouble with is probably not going to happen soon. But maybe we can make the editors faster, make it cheaper than to produce all these different versions we wish that were out there. And what time is it? We still have 2 minutes. You could have one last question if you'd like. Oh. Oh. Oh, sorry.
You're begging almost to fill us. Well, Jim, you raised a point about what's the benefit for users with cognitive disabilities or intellectual disabilities. It almost begs a philosophical question about reality. What's the nature of reality and the ability of these systems to convey what is actually happening? Yet the example you have of how people are trying to explain away why that was a skateboarder doing a trick at night as opposed to Hillary Clinton gets down to the ability of these AI systems to actually explain to a user what is real, what is actually taking place. I mean, that's a little in the weeds, but it gets down to when you're actually translating the stuff, are we actually doing it in a way that is reflective of what it actually is?
Yeah, it's a great point. I mean, I think there's increasing effort now in working toward explainable AI. That's the kind of buzzword that's going around. And part of that is also, there's lots of concepts built in there. There's trust, there's transparency, there's
bias.
fairness, all the bias. Like one of the explanations that the people had for why would they think that was a skateboard, it turned out there's a lot of skateboard images in the data set that they used, right? So. So in all of these things, I mean, and again, going back to this theme of, these technologies are potentially useful and maybe will be used by people with disabilities earlier, and they may need to rely on them earlier. And so I think these issues become very important for us to address. All right, so we are out of time. I am supposed to read this code. 1851 is the code for this workshop. 1851. I actually don't know what you do with that, but 1851. Thank you all. We will have, in this room, starting at 2, we'll have our next part of our workshop. So, please come back. Thank you.